determine whether the equation is exact. If it is, then solve it. Okay? You can see any attachment to the x, that's the m. That indicate m function as a function of x and y. Attachment to the y is n. It's also the functions of what x and y. So let's check if it's exact, whereby we're going to do the partial differential of m respect to the y. Your m is what? Is this function. This is m. This is m. So let's do the partial respect to y. Uh, Here there is no y here. So it's just like a constant sign. When you differentiate constant, it's 0. So this is where we have y. Okay, and y is in two places. It's here. It's also inside here. So it's going to be product rule. We're going to use that. So let's differentiate y here, which will give us what? And keep this one constant. That will be cos what? Cos xy. Then plus. Can you not keep this one constant? This y is constant. Keep that y constant and differentiate this. When you differentiate sine, you have minus sine xy. When you now check the function inside here, xy, differentiate that also. That's respect to y. That will give you x. So you multiply that what? Like this. Okay? Let me explain that again. If you want to differentiate with respect to pdx of cos xy, it's a function of functions. First of all, get this the root. The derivative of this root of cos is minus sine. Write the functions. Okay. Now differentiate the inner one, the inner function xy respect to y. That means this will be what? This will be kept as a constant and differentiate your y. And that will be what? Just x. So times x. And that's what we have done there. Times x. Okay. Don't forget it's a product rule. Once again, differentiate this one here. Keep this one constant. You get this. Then second part plus the y which you have done, which you are differentiated in the first instance. Keep it constant and differentiate this. Let's do for the partial differential of n respect to x. We do that also respect to the other function, respect to x. Here also, the same thing you're going to do. We are only after where there is x function, which is here. There's no x function here. So if you differentiate this one, it's automatic 0. So product rule, keep this one constant, differentiate this. So that will give you cos xy. Okay? Then plus. Let's now keep s constant now and differentiate let's differentiate cos, which will equal to what? Minus sine xy. If you differentiate cos, you give minus sine of the function. Then the next thing to do now differentiate the inner function respect to x. So this will be constant. You're only doing x, which is 1 times what? Times y. You just bring your 1 outside. X, y. Okay, and we check it well. They're the same thing. So this what? This exact. This partial differential of this respect to y is equal to partial differential of n respect to x. It is what? It is exact. Okay. So that one has been done. It's exact. Then the next thing to do now is that if it's exact, then solve it. Give us the solution. Okay. So if it is exact, then it means that there is this symbol means there is a function. There is a function of these two functions such that either partial of x respect to x is equal to m. Okay, I'm going to take one such that either partial of this of f respect to x is equal to m, or partial differential of f respect to y equal to what? Equal to n. Just stick to one. Okay? Can you differentiate this? Can you integrate both sides? If you integrate, you have this m of this. Okay? Partial. Okay? Cross multiply and then integrate. Then you give us the constant of integration. This is respect to x, that will be g of y as a constant. Okay, let's substitute now. Our m is what? Check the question. This is our m, which is what? Integral of 2 over this plus y cos xy cos xy. Okay, delta x plus g of y. So that's the solution, but we need to get the integration of this expression and get the g of y. Okay, so this will be equal to the integral of this respect to x. Okay, let's do that. If you look at this well, you know, this is the sum of functions, integral of sum of function, this one and this one. So it will be integral of each of those functions. So this one, the 2 can be outside. Then you have 1 over this, which is what? Which is 2 arcsine. 2 arcsine x. Okay? Then plus, if you differentiate this, respect to x, that means y will be kept constant. Y will be kept constant. Then we have two brackets minus sine xy. Okay, and then I'm doing respect to x. That's you differentiate the inner function. Y is constant. Okay. Yeah, this is constant. You only differentiate this one. Okay, which is minus sine this. Okay, times y. Times y squared. That's g of y. Yeah, f will be equal to this one mean integral of this 1 minus this s squared dx, then plus y cos xy beta x also, then plus g of y. So that will be equal to integral of this respect to this function. That will be equal to 2 arcsine x. Integral of this. So the y is constant since we are doing respect to x. That's why I took it outside. So that will be y. Derivative of the integral of cos. Integral of cos is sine x y. Okay. Then check this function inside here, xy. The derivative of xy respect to x will be equal to what? The derivative of xy respect to x, ddx of xy will give you a y. Give you y because you're only keeping your y constant, you are differentiating x. So that will be y. So you now divide what you have there over y plus what? Plus g of what? G of that. So we now have 2 arcsine this will cancel, then plus sine xy, then plus g of what? G of y. So that's what we have now as the f. So that's our solution. But that we need to get the g of y. That's what's left now. And to do that, we differentiate partially with respect to y. So and that will give us partial differential of f respect to y will be equal to if you check this one, this first one here, there's no y there. So if you differentiate that respect to y, this will be 0. Then we'll come back here. If you differentiate sine xy, that will be equal to cos xy. Okay, then check the function is respect to y. Any attachment to y is x. Then use it to what? To multiply what? The expression. That will times this. Okay. Then plus what? plus g prime of what? So if you differentiate your g of y, to give you g prime of y. Okay, and don't forget the differential of this is very simple. Just differentiate the root first, which is sine. That will give you cos. Okay, then now look at the xy. Since we are doing respect to y, okay, the derivative of xy will give you x, and then use that x to multiply that functions, or the attachment to that y is x, then use it to multiply. Okay, so that's that. Then don't forget your theta f theta y is called n, which has its own value. It's called n. Okay, and the n value is what? X cos xy minus y minus 1 over 3. Okay, that's your n, which is equal to what? Which is equal to this x cos xy plus g prime of y. So this one and this one will cancel. We now have g prime of y equal to what? Minus 1 over 3. Okay, then to remove this differentiation here, integrate both sides respect to y. Then you have g of y. You have g of y equal to integral of what? Integral of the minus can come outside. Y minus 1 over 3 dy. And that will be equal to minus here y minus 1 over 3 plus 1. That will give me minus 1 plus 3 over 3. That will be 2 over 3. 2 over 3. So over 2 over 3 here. And that's equal to plus C1. Or C1. The C1 is just the constant of integration. Okay? Is equal to minus y 2 over 3. This fraction here, there's 1 here, so it's going to flip upside. You have 3 over 2 plus C1. Okay? So that's g of y. So just go to where you have g of y. Go to that function, which is somewhere here, which is here. Yeah, which is the one I start here. So f now become, your f is now, and let me use the space here, f is equal to 2 arc sine x plus sine xy, then minus 3 over 2 y 2 over 3 plus c1. And don't forget your f is what? Is c. So final solution, the solution is what? The solution is now 2, the solution will be, the solution to that will be equal to 2 arc sine this plus sine xy, sine xy minus 3 over 2 y 2 over 3 equal to what? Equal to c. So that's the solution for that differential equation. That's the solution to that. That's the solution to that. Okay.